Right, cool. We're live again. Right, this stream is live again. Cool. Oh, my hair is horrible. Alright, let me. Nah, that's worse. That's actually way worse. Right, cool. Right, so I was working on my Raytracer. Or was it? Right. Okay, yeah, I remember what I was doing. Can I refresh? There's some cool options here. Clear my chat. There we go. Huh. Damn, there are a lot of things here. Right, sorry, I was just looking in some streaming settings. Kind of curious what I could do there. A lot of things, apparently. Alright, cool. So, we were working on the ray box intersection. Right. Sorry, we were finishing up with the BVH. However, we never seem to intersect with triangles, what is kind of a problem. However, do I ever hit this part? Let's see. It's interesting how the game window or the Raytracer window on stream shows code. I think it's mainly because it's what do you call it? Rendering still. But yeah, that's fun. So I'm just trying to figure out why we're not intersecting things. Right, so have we drawn the cow yet? No. Because debug, why would it take less than 3 years, right? Right, so this isn't triggering. However, let's double check if this is actually correct, right? So we have, right, triangles. So the index is 3, okay. Let's go to 3, and it's, let me take a quick notepad. Right, you can't see this on stream, but that's fine. Right, so the, yeah, sorry, yeah, right, so these values, so okay, sure. So current node bounds, so it's -3 on the x-axis, right? Okay. Model the triangle 3. Sure. So that seems to be fine. The x-axis, right? Current node, where is it? Current node dot bounds. The y is -3.35 and -1.2. So it's 3.4 something, yeah, so that fits. Wait, -3.44. I don't think that fits. -3. No, that can't fit. I don't think that fits. This is big, right? So y is minus 3.34. However, if we go to triangle 3, this contains a vertex that has a y of minus 3.44, meaning that the BVH isn't constructed correctly, because the BVH should encompass all the vertices. So that means something is going wrong with the bounds. Okay, that's good to know. It's very interesting, actually. Right, so why is that going wrong? Okay, let me see. So we calculate in the partition, right? We have this part, I think, that is for the bounds, right? So this takes the vertices, what's 0 to 2, so index 0, 1, and 2, and does min max, right? Interesting. But that should be enough for getting the vertices, right? Because this should simply give me the minimum. So how did we ever get a vertex that didn't fit in the bounds? So, you know what we can do? I can make a small temporary function in here. So a bool fits in BVH, fits in the bounds. So this takes a const glm const glm vec3 reference array of 2. Bounds, and it takes RT and takes an RT triangle reference, like const reference, and this is triangle. Sure. Wait, how did I pass in a const array again? C++ C array reference. Right, okay, so it's double. Right, okay, cool. So, if, so we need a simple bool fits, and this is set to true, then we loop over for E. E is 3 because we have 3 vertices on each triangle, and then if triangle dot y dot x wait, why can I not? Oh, the get first dot y dot x is greater than or equal to triangle sorry, is greater than bounds 0 dot x, and let's actually store this here, right? So so const auto ref verts, and that is equal to this. And then verts, yeah, and verts dot y is less than or equal to bounds 1.x. And if this is false, yeah. Why is oh sorry, this should be .x, right? So if that is true, then fits equals false. Right. And then we just need to do this for all the accesses. This is not, you know, very beautiful code, but should be good enough for some debug code, right? Z, and Z. Right, so if fits debug break and return fits, right? And then we, in the intersect here, we want to simply do model, so fits and bounds model dot triangles dot index dot oh sorry, so this should be I need to get the bounds here. That's current node dot bounds, and then right. So this should actually be a std, sorry, so a const std array of glm factories. Sure, and that should be fine. Yeah, we can just ignore the return result. That's fine. So let's see if this. Let's see if this triggers. Oh, that triggers. That's good. Well, I mean, that isn't good, but that's fits my suspicion. Right, so we have bounds. Right, so was it -4? No, just 4. So we have negative indexes here. Yeah, so this doesn't fit at all. Like, these bounds are completely wrong. Like, look at this. These don't fit at all. Like, not even close. This is 4, 0.6. Like, this is between 4 and 5. But this triangle is, like, in the negative. So these bounds are completely wrong. Right, that's actually very good to know. Because now we know that we have a problem with the generation. And we're obviously never going to get proper intersections if the triangles don't fit correctly in the bounds. That will give us garbage results. So the subdivide, right? Right, we put the partition. In here, we create the bounds. So let's do two fits and bounds. std array, glm vec3, 2, and then bounds left, comma, vertex array. Well, oh, it's a private variable. Right, and it's right. All right. And then for bounds right. No, we actually need to do this in here. Otherwise it's never gonna work. So fits and bounds right, right, bounds left, bounds right. And then the triangle, sure. And then in here we had the fit bounds, but we don't actually want to have this one triggered. Well, where did I put it? I mean, I could just simply find usages. Right, yeah, in this reverse PVH, right. Coming out. And we triggered it. Awesome. So it's triggered from here. Okay. Interesting. So vertex array. Add to can I get this value? No, okay, right. Let's do it slightly different. So instead of putting the break here, we can simply put it in here. So if fits and bounds, debug break. So if this is false, right? And then we actually get it in the local scope, so we don't have to go to the call stack and confuse Visual Studio. Call this immediately. Right, so vertex array, so bounds left is minus 4.44. Minus 4.42. Oh, minus 4.44. Wait, what if this works, but it's complaining? Right, I kind of hate that's hard to debug this. Bounce left, right. Copy value. Just copying the values in a notepad. Right, you can't see this, but believe me. Copy, right, so that's the first node. And then the second node. Oh. It's a slow process, but we're getting there. Copy. Right. So I got the values here. So the vertex array should right. So minus 4.42 is between the arrays. That's correct. Okay. So the y, this is equal to the minimum. So that's okay. And the z is 0.13. Yeah, so that's correct as well. So vertex 1. Minus 4.38. Yes, that's the minimum again. The y is equal to minus 1.9. That's fine as well. And the z is 0.04. Right, so this is also the minimum, or a minimum. So minus 4.443511. Yeah, sure. Minus, yeah, sure. It's minimum. Right, I think my function is actually wrong. Right, so this takes greater than or equal, right? No, if it's equal, it's actually fine. It's if it's within no, shit, that's less than or equal to, right? No, if it this is, so this will evaluate true, and if it's false, so if it's true, wait, is this literally doing the opposite thing that it should? So this is true, then it's false. Yeah, no, so this is correct. This is correct, right? So if it's false, then it's true, and then it will fire. Yeah. However, we can simply do plus floating point epsilon, right? And here minus so let's see what this does. So this should give it a bit more leeway. Right. So is this the same one with 0.44531? Yeah, it is. Right, let's put some breakpoints here and see which one it triggers on. Because it's still the same one that we're getting. Right, it's this one, okay. Minus 4.24. It's infinite. Huh? Huh? Why is this infinite? This can't ever be infinite. This is impossible to be infinite. Huh? That's actually odd. Yeah, I'm actually confused how this can be infinite. So these values are normal, but the bounds are infinite. Okay. If I look in here. Oh! Right, yeah. I see what I did wrong. Yeah, right, so this should be bounce left, and this should be bounce right. I had them swapped around. Right. So let's see now if we trigger it. Hello, Sephian. Yeah, I thought the face cam would also be a bit more personal than without. Especially because it adds a lot of emotion, like my perpetual confusion on why my code isn't working. Right. So now this is still triggering, but now we can actually see why it wouldn't be triggering. So right, so this would be 1.00, and this is -2. Right, so this is greater. So this part is. So I think I can actually do this. Right. So. No, this doesn't evaluate. That's a shame. Okay. Right. So this is true. And this is false. Yeah, everybody's here for face cam. You want the feet? Oh, shit, that's a bit fun. Yeah, there we go. Look, it's some good feet. Wait, okay, you want the other one as well? This is the left one. No, we don't do nations. You guys. You guys are insane. Yeah, some good feet, right? God damn you guys. Oh. I see what. Yeah, fun guys. Wait, do you all just take a break from D&D to watch my stream? I have fun with D&D, guys. Is the session fun? Maybe. Well, that's very promising. Okay. So now, according to my code, everything does actually fit in the box. Says. Okay. Right, so where was I? Right, so it's I was doing the thing. Yeah, I don't know what I'm doing either. So you're not the only one, Nico. Right, so in the traverse, right, we can do the fit and bounds check again and see if this. So if fits and bounds is false, then deep break. No, that's not where that's where the lumbar thing is. Right. It triggers. Okay, this is big. This is big. Right. So why does this not trigger? So this is minus 5.33. Okay, this is odd, right? So there's definitely something with. How am I distracting you, Gabe? God damn it! Then don't listen to me. Much easier. I would ignore me as well. Much smarter. Right. So there's definitely. I can see what's going wrong here, right? So this should never trigger, because if this triggers, that basically means that a vertex is outside of the box, and this isn't just outside of the box. This is like massively out of the box, like very much. So why does this get out of the box? Okay. So my guess would be for this is, what if we're sorting Right, because the idea, right, is that we're sorting in place for the BVH, and it's fine if we sort in place for the two children nodes, because in case it happens to be that the splitting is not worth it, those two nodes are just still one node. So even if we sort in place, that's fine, because they're still the same result. They still fit in the parent. And we can see that right here as well, that all the nodes fit. However, what I can do is, instead of having the breakpoints here, in the build BVH, I can simply loop over... I can loop over the nodes, right? Nodes... So it should be pull pointer. Right, so it's less than pull pointer. So if m.node dot m.nodes dot y dot count does not equal 0. Yeah, so that means it's a branch node, right? We loop over for e, and this is triangle, sure. And then there should be m.nodes dot y. Oh, I can't type holy. Dot count, right? So if any of these, so if m dot yeah, right. So if fits in bounds, m dot node dot y dot bounds, right, comma model dot no, we could just simply do this, and then this is m dot nodes dot y dot left plus triangle. Yeah. So this y was the pull pointer. This is the current node. Yeah, this should work, right? And if that's the case, we do a debug break. Right, so this will loop over all the existing nodes and checks if the if they actually fit right in the nodes. So we can actually test with this if the nodes themselves are actually correct or corrupted. Or corrupted in the sense that some data is being sorted in a way that shouldn't be happening. Okay, so we are actually triggering this, right? So what so we're getting y I24. Okay, man, that joke is actually hilarious. No, I actually really like that joke. No, that's actually a really good joke. Right. Nah, welcome, man. Welcome to the stream. So, I'm currently working on a Raytracer, and well, I'm trying to get the BVH working, but the BVH isn't really cooperating. So, if you don't know much about Raytracers, BVH is stand for Bounding Volume Hierarchy. So we're basically trying to subdivide a model into boxes so we can get the correct triangles faster. However, it seems that there's something wrong with the construction, so the wrong triangles are getting in the boxes, because the triangles should fit in the boxes, but apparently they don't. So I'm trying to figure out why that's happening. But it's a nightmare to debug, because it takes a while to build, and simply debugging it is really hard because you can only see numbers, right? Right, so apparently node 24 is wrong. Debugging is interesting. It's a love-hate relationship, right? Okay. Right, so this doesn't fit. there's definitely something iffy going on. Yeah, no, it does for sure. And the worst thing is, right, I know what is wrong here, but knowing, or try to say, I know what is going wrong, but figuring out why it's going wrong is the harder issue. Especially with this, it's you can't see it, right? So if your shading is messed up, right, you will simply see like a black model or a weird shaded model. But with this, it's all very abstract. You can't really debug it without it's either correct or not, right? So you need to look at the numbers and try to understand if the program is doing something correct. Right. So this is apparently going wrong. So left plus triangle is 0, right? So this should be indexed 1. And this doesn't fit, apparently, right? Yeah, this clearly is wrong. So there is definitely something going wrong with the partitioning. Because the interesting thing with the debugging here, right, is so in the partition function, we are checking... yeah, so I pretty much only know C++, really. I have ordered actually a book to get into Rust, but I haven't got the book yet. It's still on its way from America. So I'm only really familiar with C++. I have done a little bit of Java in my past to try to learn to Minecraft, but that's been a long, long time ago. So I haven't gone past the basics there. But yeah, my education, I study game programming, is pure C++. So it's what I am used to working with. Although I would like to learn some other languages. Because, like, I kind of want to get in Python because it's very interesting to... Okay, these are awesome, man. No, these are actually funny jokes. But yeah, no, I'm familiar with C++. It's a great language. I absolutely love it. But it's such a massive pain to do anything, right? Because it's so syntactically heavy, or just the getting all the code correct to even do a simple thing is so much work. Something like Python should speed up the work by so much, hopefully. Nah, man, it's completely fine. Oh, I'm from the Netherlands. But yeah, it seems I've actually got quite a weird accent. I'm kind of... I mean, most of my English is actually self-taught, so I think I've taken a lot of accents from different cultures. But yeah, I don't really know. I have a bit of a weird accent from what I know. But yeah, I'm from the Netherlands. But I don't really know what my accent would be. Because it's not like the typical Dutch accent, right? Because I don't really know how to describe the Dutch, like, English accent, but you'd immediately notice it. Right, let me see if I can get a video of it, right? Yeah, I can't really find a good video real quick of the accent, right? But you immediately usually notice the Dutch accent. Yeah, I think one of the reasons that could be, right, is that in school I did Cambridge English, so it might be that I've taken influences from those classes because they want to teach you like the proper English, right? So the UK English. So I might have been that my accent is a bit between there, right? But again, I don't really know where it's from. But one thing I do know, right, is that I very easily take accents on. So at one point we had a exchange student from Italy, and because he had like a thick Italian accent in his English, and at some point I would start taking on the English as like his accent as well, kinda. I like I didn't mean to, but like for some reason my voice started doing it. So that's kind of interesting. But yeah. Where are you actually from, man? Oh yeah, that's tricky then. Yeah, I mean no, but you're a programmer as well, man, or yeah, I still want to go to Ireland at some point. Hmm. I mean, I feel the accent is also very dependent on how you get taught English, right? Oh, awesome! Yeah, I am a second year student, so I have 1.5 year more. Right, really, Nico? Damn. Yeah. But yeah, I think I know what's going wrong, right? So, in this code. So, what language do you actually use? Is it how do you pronounce your name? Yes, Yesi Sour. Ah, yeah, Java and C Sharp. Yeah, SQL. Yeah, I've actually no, I did SQL once in high school. Ah, Yesi. Okay, cool. Ah, right. Yeah, I see. Right. So, something that bothers me with this code is if I look in the notes, right? Uh, there are duplicates here. So 0 and 1 and 1 and 1, right? So there shouldn't be duplicate nodes, because every object should only, each node should contain different objects. So what I'm thinking is happening is that we're getting nodes, regions being swapped again, causing stuff happening there. So we can look into that. So models are being swapped. Is Angular that bad? Because I've actually... wait, did I? I think I might have looked into Angular once. Let me check. I think I might have done a like Code Academy thing on Angular, but I think it's like the very basics. But really, okay, that's good to know. How is C Sharp? Because I know Unity, for example, uses C Sharp, but I haven't actually used C Sharp before. From what I've seen, um, awesome. So from what I've seen is that C Sharp is relatively similar to C++, but it does quite a lot of stuff for you. Because I know with C++, I have to do everything manual. Like, you want a reference? Well, you got to say that. If you do something wrong, it's well, it's your fault. Right. So in the partition. Now let's see. Where is the? There's it. But yeah, C Sharp has been looking interesting. I've been wanting to get into it mainly because of Unity, because in school one of the projects we use Unreal quite a lot, but I absolutely I despise working in Unreal as a programmer. It's such a pain to do everything. All the things you want to do in Unreal, it's like the Unreal way, or well, I guess I will just crash, right? Yeah, but I mean, so is so C++. But yeah. Because I mean, everything is case sensitive in C++. So std string or std string. Oh, right. These are different things, right? Yeah. So Arduinos can actually run C and C++, I think. Yeah, you have a bunch of different versions, but I know the Arduinos run C++, right? So one of the other things, so I've been working on a custom lab project. Right, I'm trying to get some. Right, my circuit board. Right, so this is some terrible wiring, right? But ignore that. But there is a tiny ESP32 board here. Right, yeah, this thing, right? So this runs, for example, C++ as well, I think, or C, one of the two. That I used to. Yeah, it's horrible. I know it's, but it's still actually in working phase, so it's kind of horrible. But forgive me. I suck with electronics, like I actually do. But this magically works for the most part. But yeah, it runs on C++. It actually has Wi-Fi connection as well. It's really awesome. I completely lost track what I was actually doing. Right, I was checking the BVH, right. Wait, a color sensor. How does a color sensor work? Is it like just a regular camera that just makes a picture and then it just reads the RGB value, or? Um, ah. Oh, okay. Right. I see. Okay, I see. Right, that makes sense. Right, so what I'm thinking that's going wrong, maybe I'm setting up the. Oh, that is fucking sweet. That's actually big brain. Did it actually work? Like, did it give you good toast? Because if it gives you good toast, that would be like the best invention ever. Oh, make a Kickstarter, man! No, but that's actually really awesome. I'm curious if that could actually be um, interesting, like in a real toaster. I mean, you could do time based, but I mean, I'm curious if there are toasters that actually do that, because I didn't think so. But wouldn't the something I'm curious about, right? So the toaster would generate quite a lot of heat. Is that fine for the wiring and like the sensors? Yeah, I was gonna say, right. Yeah, that was what I was thinking, right? Like, you can't have the sensor being outside because you would simply, or sorry, inside because it would melt, and you can't have it outside because, I mean, you need, yeah, I see it through the toaster. Ooh, that's pretty cool. That's actually pretty cool. Alright, so alright. So the count is correct as count minus pivot. So something I'm curious about, what if the if we're having an issue with the pivot, what if the pivot is a one-off thing, right? So return. I'm looking at the other Raytracer I have to see if I do anything interesting with the pivot. Yeah, that sounds like an actual programmer thing. Like, well, we need to get it in the toaster. Let's just remove the side panel. Let's just cut it out to do the trick, right? It's completely fireproof as long as nobody puts anything in the toaster, right? Completely safe. Yeah, exactly. Yeah, it's just say we won't do it, and then it can't happen, right? Easy. Exactly. Yeah. I mean, how can you know it doesn't set it on fire if you don't test it, right? And even in worst case, like every building has a fire extinguisher, right? So it's fine. Right. So what if this is just a wild idea, right? We do the pivot -1. Because what if the pivot is no, let's keep the pivot like this, but what if the pivot here is info.pivot -=1. So what I've been thinking, right? So we keep adding 1 to the pivot, but what if the pivot is like a one-off error? Right. So as for games, I play one of the few games I play is Arma 3. So a bunch of my friends that were in the stream a second ago are friends from Arma. Lately, I've been playing with people. Is it Hearts of Iron? Oh no, Men at War, I think. Let me double check. I keep forgetting the name. Yeah, Men of War Assault Squad 2. What's really awesome in PvP. Okay, that's definitely not correct. What else do I actually play? I've been lately getting in Factorio. What's a terrible idea? Don't ever play Factorio. You won't have time anymore. Yeah, I used to play Call of Duty a lot, but lately, I don't know. I used to really like it, but at some point, I kind of felt it was just the same game over and over again. I kind of lost interest. Yeah, Factorio is awesome, but it's an endless cycle of the factory must grow, and yeah, the factory must grow, right? How? Why would this crash? Yeah, that's the one thing that's actually true. COD is great with friends. Yeah, no, that's definitely true. I'm the same there. I like COD way more with friends. So why would this crash? Right. Yeah, I've seen videos about Rust. There is one guy that did. I think he plays like what is it, like tens of thousands of, like 10,000 sails on the ship, and it would like go like as fast as it could ever go. I mean, it probably is, especially. Did Rust support multiplayer? I don't remember. I think it did, right? Yeah, I was gonna say. I think it's. Um. Yeah, Rust is. I usually prefer multiplayer games because it. With most single player games I play, it kind of feels pointless, right? Huh. Okay, that's awesome. So why would this? I'm confused why this would crash. Because it's a UN32T. Yeah. I mean, potatoes are always important in any game, right? Potatoes are the #1 priority. Wait, is this the print F that's crashing? It's the print F. Why is the print F crashing? Huh? What? How does the printf never crashed, and now it's crashing? That's the weirdest thing ever. Okay. I don't know. The print has literally been working for like 2 streams. No, it's just printing some. No, it's just printing to integers, but this print has been working for like 5 hours now. No, okay, not 5, but it's been there for quite a long time now, and it's never crashed. And now I've had it like, so I want to know something fun, right? So let's comment at this line, recomment the print, and now it's gonna work. Now it doesn't crash. No, only this line I added, right? So that didn't. This doesn't crash yet. But if I redo this line, it suddenly crashes. And that's the weird thing is, right? The pivot has nothing to do with these values because we're printing different values than mentioned here. So can we crash? Right, now it crashes, right? And we can see in the call stack here that it's coming from a printf. But the weird thing is, right? Like, these are all valid values. How does it print in? Like, how does it crash in the printf? Because in the call stack, right, we go in the printf, then somewhere deeper in stdio. How is that a thing? Oh. What if it's just trying to print the same thing? I do have an idea. No, I can actually do minus minus as well, but I was just trying some things. Even though it makes no difference, this works as well. Actually, I could just simply do this, the predicate. What's actually better? But yeah, it might crash for another reason. Maybe it's crashing for some other weird reason. Maybe it's some kind of Stack Overflow, because it is recursion, so maybe it's doing something weird there. But it's definitely not this. This line doesn't work, because even in release it crashes somewhere. So I'm just wondering why we're getting duplicate nodes. Because, wait, let me walk through this code, right? So the idea is, right, so we're basically doing binning. This is technique where we basically try a bunch of different splitting points, and we see which is the most optimal, right? So we do everything 3 times because we have 3 x's that we can split along, right? So x, y, and z. Then we have the distance, and the distance is simply between the 2 points on the... It's hard to distance reverse, right? So we have 2 points, and we just need to know this distance, right? Because we need increments, equal increments between those 2 points. So that's simply this distance divided by number of splits, what's simply define that is currently set to 16. So that means that we're on each axis we're testing 16 different positions and seeing what's the best one, right? Then we loop over the possibilities, but we start at 1 and for the error code I don't remember what they gave, but it's I think I'm definitely doing something else wrong. No, it's the printf itself should be fine. I think it's something probably with recursion, maybe running out of memory. Who knows? If I looked in the print statement, it was doing some weird stuff as well. But it's definitely not the pivot. That was a weird idea. Right. So then we're I could try that, but it's not going to make a difference. Oh yeah, what was it? Right, with the code, right. So we skipped the first and last index, mainly because it doesn't make sense to split on the very edges of the bounding box. It does, but I know for a fact that why it crashes here is to do with the pivot line. It didn't crash before, so there's definitely something going wrong there with the partitioning. If I add the pivot minus, what I shouldn't have to do in the first place, right? But yeah, yeah. That's wait, what? That's odd. Why would you need to run it twice? That's very weird. Very weird. Right, but sorry. We skipped the first and last one because it doesn't make sense to split on the edges of the bounding box because there are no shapes going to be in there. Then we get the current split point, what is the left bound, and then the axis point. So this would be x, y, or z, plus y times the increment. Wait. Okay, very, very interesting. But yeah. Then once we have the split point, wait, I'm actually doing a bunch of unnecessary sorting here. So I just that's fair. So I'm actually noticing something here. I'm sorting the array every time for every split, but I don't need to. I only need to split it once for every axis. That actually should make a massive difference in performance. It's probably not going to fix anything. Because we basically sorting it in from left to right on the center points based on the axis that we currently have. So we have a sorted list. However, I'm sorting it for each split. So we're doing 48 sorts instead of 3. What is way too much. Because we don't do anything with the sorting. We just use it for partitioning, right? But it shouldn't change anything code-wise because we're still sorting the same thing. It's literally sorting it this exact same time 16 times. However, I'm kind of curious now if this in debug now goes much faster. I think that's a bit faster. Maybe. It's still giving me these things, right? Maybe it's faster. It should be. Right, so to continue, where's the code partition? Right, so we sort it once to get we basically sorted on the x and y axis. We sort the centers based on either x, y, or z position in ascending order, just to make the partitioning easier. Oh, thanks for the follow, man. Right. So then we have the current split point. What is the basically just the left plus y times increments, and then we need to calculate the bounds. What's the left and the right bound? Right. So to calculate this, we need to loop over all the triangles in this section. What would be the first? Yeah, that would be first. What would be yeah, the first index in the array, and then count. Yeah, this should be correct because we're skipping it. And then we simply add 1. And then we check if the center is less than the split point, it's on the left. And if it's on the right, it gets put in the right bound, right? And then we simply have a value, the pivot, that basically says where in the array the actual cutoff point is. So this just gets moved along, and then we simply get the triangle and loop over all the vertices and make sure they fit in the box. And we know for a fact this is correct. As in, when this code runs, all the triangles fit in the box. That part is correct. And the same for the right bounds. They both fit into the bounds correctly. Then, once we know... thanks, man, for joining in. Have a good day and Merry Christmas. Thank you for joining in. Yeah, I don't know how long I can stream for today, mainly because, you know, it is Christmas, so I probably have to do some family stuff later today. But yeah, thank you very much for joining. Yeah, I'll try my best. Thank you. Right, so then the last part of this is... yeah, thank you, you as well, man. Right, so then the final part of this is calculating the cost of splitting, right? So we calculate the... yeah, see you, man. Thanks for joining, it was awesome. We need to calculate the cost of the... of splitting, right? So first we get the bounce left, bounce right. This is basically just the width, height, and depth of the box. Then we calculate the surface area with this formula. I mean, it's not really a formula, but basic maths. So this for the left box, right box. Then total surface area and the splitting cost. So the splitting cost is equal to the surface on the left times the number of objects in the left box, in the new left box. And then to the right times the number of objects in the right box. So if this splitting cost is less than the cost that is already there with the root nodes, we want to split. If this cost is actually bigger, it's not worth splitting, because splitting would have a bigger cost than we would gain if we split it, if that makes sense. And then we just fill in some information. And then here we have something, so if we didn't split, we simply return. And if we do split, so because we keep sorting for each axis, right, we need to resort in the very end. Because we need to sort on the actual correct axis. So, yeah, so we pass in info and we do split axis, right? Yeah, so we need to sort once more on the final axis. Because we need to sort on the x, y, and z first, but say it's the x-axis, we need to resort on the x-axis. If that makes sense. And that's basically the entire partition info. However, we have sorted this array, right? But we don't sort the entire array. We simply sort from the part that's in the box. So first plus count. So in case we try to partition the node, we move the items around instead of that around. However, we notice, oh, it's not actually wharf splitting again. This area is still, even though it's rearranged, it's still the same area, right? So when we intersect, we still check all the triangles in there. So the order doesn't matter. However, if let me get Paint open, right? So let me open Paint. Right. Right. Okay. So we go Paint now here. Right. Right. So let me draw the situation real quick. Right. So we have imagine this is an array with all the triangles, right? So we have a bunch of indexes here. I am such a great drawer. So a bunch of indexes here. All right. So then we have a node. So let's think. New, and we have a node. This node is in red, and we say, hey, this node contains these triangles, right? Right. Yeah. So it contains these triangles. So even if these are rearranged in some order, that's fine, because they can still contain the same triangles. However, let's say we have a different node, and if this node contains these two. This is valid. This is perfectly fine, right? So we have two nodes. They touch completely different things. This is how we want it. But what happens? Let's say we have another node, and this one actually is like this. Right. This node contains these ones. Now we have a problem, because if we now, for example, swap these two, what would be considered correct in the orange one, it would be incorrect in the yellow box, because now the yellow one is referring to a node somewhere completely outside of it. So we're basically contaminating the other nodes. However, this shouldn't be happening. But it is, I think. Because if we go in here, so if I put a breakpoint in the building of the PVH, right, let's go back to Visual Studio. Right. No, I don't want the deeper break. Let me just comment this out real quick. Actually, I can just comment out this entire part, because I just want to show one thing, right? So if I run this, it will at some point in the very future trigger here. Okay, right, there we go. And if I increase this a bit, we can see in the nodes, right, that we're getting duplicates. So we have 1, 1, and 1, 1. So this should theoretically be impossible, because that would mean that we have duplicate nodes. But we're getting duplicate nodes, so that would indicate that something is going wrong with the partitioning, because each node should be different. But in case we have something like 1 in count 2, I don't know if we have one, but so we have 2, 1, and 3, 1. All right, so we have 3, 1 here, and we have 3. I saw another. I think 3. I think I saw one with a 3 and something bigger. Yeah, so we have 2, 2 here, right? So we have 3, 1, and 2, 2. So that means that the node in 2 could be swapped with 3, 1, and 2, the node at index, the triangle at index 2 could be swapped with the index at number 3, and then we would have an issue. It would be wrong. So there's something going wrong here. So to go back to Paint, right, to visualize this. So bring Paint back. So we have one node that is this region, right? Let me just get the pencil, bigger size. So we have one node now that starts at 2 and is this size. Yeah, I will, fellow, if you give me 2 seconds. And we have one node that is here. So if these two get swapped, we would get wrong information, right? Yeah, so I can definitely give you some summary of ray tracing, right? So ray tracing is, I would say, actually the simplest rendering technique there is, because basically what you do, you have a camera, right? A virtual camera, and in each pixel of that camera, you shoot a ray, and that ray simply travels through your scene, and if it intersects something, it says, "Hey, this is what I hit." Then you know, okay, this object I hit. But then you can apply different things. You can apply shading, you can apply reflection and refraction. And the advantage of ray tracing over rasterization, which is used in the majority of games, is that you can get really accurate and nature realistic effects. However, it's a much more intensive process. So it's way slower than rasterization, but it's much more accurate. Right. So I can actually show you what this can do. So this one isn't currently working because we're having some bugs. However, I can show you the one that I worked on last year. The stream might be a bit worse because it's using my entire CPU. Right, there we go. So this is the Raytracer I made last year. So this is absolutely frying my CPU. So the stream might be lagging a bit. So we'll try to keep this short. So I can give very accurate shading, very accurate reflection, refraction. So you can actually see perfect reflections in the sphere, how it actually would look like. Same with refraction. So the this one is actually made out of like a glass material, and it bends the light. So if you move around, this is how it would actually look in real life. Because the glass warps the light, basically. So yeah, it's really powerful, but yeah. Awesome. That is helping. But yeah. So that's kind of my goal I'm working towards. However, the old project uses primitives, so spheres, planes, triangles, boxes. However, all the virtual functions had applied quite a big overhead. So with this project, I've opted to skip primitives completely and just stick to triangles. However, since I started with triangles, that means to get anything really working, I need basically a model, right? And the model consists out of the cow that I'm trying to run is like 5,000 something triangles. So for each pixel, I would need to do 5,000 intersection tests. So 800 times 600 times 5,000 is... so 800 by 600 by, I think, like 5,500 is like 2.6 billion. Yeah, billion. So 2.6 billion intersection tests, at least. And then we still need to apply shading and stuff like that, right? So that's insane number of calculations. However, with bounding volume hierarchy, we can get this number down drastically, because instead of say 5,000 triangles for each pixel, we would only have to do 30 or 40 intersections. So 800 times 600 times, let's say 30, would be 14.4 million. Yeah, I really like Raytracing. It's very powerful. But yeah. So instead of 12.6 billion, I said. Sorry, that's a dot. Yeah, 1.2 billion divided by, what did I just say? 14 million. Right, so that would be 85 times faster with a BVH. So instead of my cow taking about 4 seconds to render, it would hopefully do it in 30 frames per second. I hope that's a goal, right? However, BVH is one of the, in my opinion, hardest things to make because it needs to work basically in order to actually test it. Because you can't really test anything in the BVH before it's done. You can only look at the numbers and see if they could make sense. Yeah, it's insane. No, it's not 85%. It's 80. It's 850 times. So 850%. So instead of about 4,000 milliseconds, we would go to so 4,000 divided by 85. We go to about 47 frames per second. 47 milliseconds per frame. So 1,000 divided by 47, that would be 21 FPS. It's not ideal, but these are all rough estimates, right? And with a BVH in place, it would take very little. Adding more objects and more complex objects would be very limiting in impact, right? Because a BVH theoretically drops the number of intersections in 50% each time. So the cost of, for example, a model of 1,000 triangles would be marginally easier to calculate than a model with 2 million triangles. The difference would be, for example, 3-4 intersections, what's nothing. And we can make a BVH out of hundreds of objects. So we can find the correct object in the scene really fast, and then the correct triangle on that object really fast. So it's very important to get this right. But it's really hard to debug because it's just numbers still works. And I don't have a method of really visualizing the BVH either. What would be nice though, but Subsiphon. No, I don't think I can make Skynet. I know a friend was into AI, but Skynet is a tall order. But yeah, BVH is massive in a Raytracer. I do actually have something cool. Wait, actually, I have actually something really cool to show. Yeah. So let me take this scene. I need to figure out how I did this again. I luckily have some help things. No, wrong menu. So I could Oh, right. So this is the BVH viewer I made. Right. So this is the note, right, that you can currently see. Then if I go, right. So apparently this is a bad scene. Never mind. I need a different scene. No, wrong button. It's actually really struggling. Right. Okay, we're actually moving now, finally. Right, so this is actually, with this one, I can actually visualize the BVH a bit better. So, Yeah, right. So this is the root node, right? So we can see that all the boxes are contained in this one box. If we go further, wrong way. If we go further, we can see that, hey, it contains now 2 boxes, and basically the scene is split. And we go again. So let's say we hit the left box, we already eliminated 75% of the scene. One more box, we eliminated 87. This goes on, right? And in the end, it looks very dense, and then suddenly there are a few more. Yeah, basically, right? That's basically what it does. So you could eliminate 50% every time. So I think there are, if I go to stats, this is depth like 10 or so. Yeah, so this is 10 layers. So that would mean that with 10 intersections, we know which box, or ideally in 10 intersections, we would know which box we hit. And then we would need another 3 or 4 to go through all the objects in that box. So when in 14 intersections, we know which box we hit in this scene. What is, I think, blowing, right? So yeah, it's very, very powerful. But this this program here is using an overhauled version of the BVH. This one actually uses something called surface area heuristics. So it actually analyzes the cost of splitting. So it's quite a bit more sophisticated, but it's also more expensive to calculate. But the idea here is, right, that for each model, we only calculate this once. And then with transforms, we can simply move the BVH. So we calculate this once at startup. We could even save this in a file. And then once we load in the model, we could load in this BVH file as well, and we're done. That's the idea we're going with. So we can use a more expensive method to calculate this, but it will give us better performance. However, for the scene, we want to use a easier to calculate method, but less efficient. Because the scene, let's say we have a car driving around, right? We would need to rebuild the BVH every frame. So we need a fast BVH to build. However, this is only done once, so we can use a more expensive method. Anyway, I'm going to be right back. My throat is absolutely dying from the talking, and I don't have any more water in my room or anything to drink, so I'm just going to grab something to drink real quick. I'll be back in like a minute. Right, I'm back. Right. Oh yeah, but yeah, Philo, right? Yeah. But there's nothing wrong with being a scripter. I mean, there is need for everybody in projects, right? I mean, it's the same in my education. We have people that... so we basically have 3 main regions for programmers. So we have gameplay programmers, we have engine programmers, and we have graphic programmers. I am, in my education, more of a engine programmer. So we actually make custom game engines. We have graphics. This would actually fall under graphics. And then we have gameplay. And I mean, I think gameplay is pretty self-explanatory what they do. They do gameplay. Personally, I'm not much of a gameplay man. I like more the kind of challenges that graphics or graphics and engine provide. However, gameplay programmers are very essential, right? Because even if I manage to produce the most amazing Raytracer that can render a scene in 60 FPS, no problem, if there's no gameplay, who's ever going to care, right? Everybody is important in a project. That's good. But But yeah, I've worked on an engine actually last block that we almost managed to get running on the PS4, but that is interesting. However, I can't talk more than that about it because sensitive information. But yeah, the development for the PS4 is fun. And just a challenge as well, right, is to develop an engine that runs on different platforms in general. Doesn't really matter if it's a console or just Linux or Apple. Or sorry, what iOS? No, not iOS. What's the OS called? I don't remember. Anyway, making it for different OSs just to think about code in a way that would allow it to run on different platforms without making it spaghetti is quite a hard challenge, but it's awesome. Right. I'm still stuck on this problem. Why are we getting the duplicate nodes? I think something I could do is... Right, so I think there's something going wrong here. Because the subdivide is correct. Yeah. Because all the subdivide does is just sort it and then split the axes. Yeah, sorry, it does actually split. It just sorts the axes and says this on the left, this on the right. So I'm thinking there's something wrong in the subdivide part. Right. So what we do here, right? We pass in the current bounds, left, and count. Yeah. Then the node area and count. Yeah. So this is the cost part. That's fine. And then if the splitting cost is greater than this cost, we say that the left is equal to, so the left is the left node, and we return, right? So this would basically say, hey, I don't want to split. This node should terminate. Yeah. So if it terminates, right? So I'm thinking about this. So the left would be... Yeah, because we subdivided a node. So we say... Right, sorry, I'm thinking about this. Because maybe we're doing the subdivision wrong. Right, so let me open Paint again, right, and show you my train of thought. So we have the root node. We have the root node, and then we have a subnode here and a subnode here. Right. And this node contains the following info. BVH node. Paint. Oh, wrong project. No, this is the project, right? So it contains the bounds, left, and count. So if count is 0, then it's a branch node, and then it refers to the index in the node array. If it left, if count doesn't equal 0, it's the objects array. Yeah. So, getting back to Paint, right? And then Paint. Where did Paint go? Right. So then we're subdividing this node again, or we're trying to subdivide this node. However, we find that we want to terminate here. So we found out in the subdivide that this cost is too much, because splitting here is more expensive than just going through this node. Right. I think that makes sense. I mean, that. Let me see if I can get Paint and the code going. Right, there we go. So, to go back to BVH code. So we're saying here, we try to partition it. So we're trying, in this part of the code, we're basically, in Paint, trying to see if we want to do this. So we partition the objects inside of it. We move them around, we sort them, but that's fine. However, then we say, no, this is too expensive to do. So we want to set the current node, what is the parent. So that's this node, the current node. So let's just put a, this is current node. Current node, right? And we say that is info.left. And info.left is the objects that's sorting. So this would be, for example, 0, and count would be the number of objects to sort. Yeah, so that's the cost function here, right? So imagine the following, right? The PVH, each cube has a size, and we're basically multiplying the size of the parent cube with the number of objects. The two resulting boxes should be smaller, right? And then we multiply those with the number of objects in each node, and if that number is less than the parent node, it's worth splitting. However, if it's bigger, say we have the following scene, right? We have two objects, and we have a root node. But if we want to split this again, we would get something like this. So 2 boxes. This would be an extra intersection, but this might actually not be worth it. It might be cheaper to simply loop over, check the triangles twice instead of doing another box intersection, if that makes sense. However, say we had 20 stars in here, then splitting again might be worth it. So it's basically a cost between having to do more box intersections, but less thing. And imagine as well, the smaller the box gets, the less likely you are to hit it, right? So if you reduce the surface area, it's worth it because you have a bigger chance of eliminating objects. But if the resulting boxes are bigger chance to hit both of them, it's not worth it. Right. So to come back to the code, another way to terminate as well is by simply saying if there are less than 4 objects in a box, then it's good enough. However, it's not an exact science if it's worth or not, but it's much easier to build because you can simply say we have 4 objects, close enough. And again, that's cheaper because you don't have to do expensive checks. Or this is not very expensive either, but you still have to do but whatever. Where's the partitioning subdivide? Right. So, so if the cost is too high, we simply say left is left. So that would be the index of the models, and we never set the count. No, but count is already set because it's passed by default, right? However, if so then we set up the left node, then we set up the right node, move the pull pointer along, and then we subdivide again. And then we set the current node, so so this is all code that runs if it's worth subdividing. And then we make sure to set the count to 0, so we know, oh, the left is actually referring to an index. So what you can see here, right? So this is set to pull pointer, and the pull pointer is basically our array of nodes. So this basically says, oh, my left is index 22, and my right is index 23, because left plus 1 is the right node, or node on the right. However, I'm failing to see why this would produce weird results, because this part is correct. Because this would simply say, hey, this is the left, and this is the Yeah, so left is the... I think one of the things I can actually do to improve this, I can do a onion in the BVH node. So I can do onion. And a right, so union. Wait, how did I do this? I keep forgetting how I do a union in C++. Right, no, this should be... But this should be okay. Okay, I cannot initialize it. Sure, that makes sense. Right, so a onion is basically what we're doing. We have two different variables, but they both map to the same memory address. So an example that makes a bit more sense, say you have a union like this. So we have a uint32 color. And then we have a uint R, and then B, right, something like this, right? And then 16, 24, and then the one alpha, RGBA. So what you can do with this is you could access color, and color is like the combined value, but RGBA is all indexed. So they all basically point to the same memory address, but you can access different channels. However, in this case, why we want it is this value here is used for different things. They both have two meanings. So if count is 0, then it's a left. However, if count is a value, it's first. Right. So we can now basically use two variable names in our code to differentiate what we want it to do, but they still map to the same value. So they should still be 32 bytes in general. So we can say simply this is the first is now info.left. So now we can use this to make a bit more sense in our code what's actually happening. Because now it's clear that this, we're now making it a leaf node because we're now talking about first. Right. So to make sense of this, so left node dot right. So this can help us a bit, but I'm still curious how we can get duplicate nodes, because right. So yeah, C++ with Unreal Engine though is kind of cheating, in the sense that it's barely C++ anymore. I mean, it's not cheating in a bad way, right? But Unreal C++ and Unreal Engine is such a different experience from like standalone C++ that I would almost classify it as a different language, personally. But yeah, C++ is much more low level from C# what I've seen. But in return, it's very powerful. Yeah, it's very heavily modified. I mean, the language is still the same, but it's everything you have to do is in the Unreal way, right? So it's more C++ Unreal, because it's still the same syntax, still the same functionality, but everything you do is via Unreal's interface. So it works very different from regular C++, but also not in a weird sense. It's like yeah, I think you can see it like this, right? So imagine you're a car mechanic. You know how a car works. You're always used to fixing Toyota cars, right? However, somebody brings in now BMW. You know how the car works. You know what the components do, but how it looks is still different. So you have to get used to how it's done in that car, right? If that makes sense. So it's still the same. I drove my headphone cables. So it's still the same thing, but it's just different. Right. So to come back to this, so on the left node, so now we actually do subdivide, right? So wait a second. Yeah, I'm using real C++, the real manly one. No, but there's nothing wrong with Unreal C++. I mean, I personally hate working in Unreal 4, but there's nothing wrong with it. Yeah, pull pointer is 1, right? Yeah. Right, so we set the... first there we get the left node, what is the current pull pointer. So that would be, if we start from the root, this would be value 1. Then we say, hey, the bounds for this is what we got from the partitioning. And then the left is what we started with. So this would be in the first case 0. And then the count would be the pivot. So it would be, say, 0 to 255. Then, for the right node, it's simply pull pointer plus 1. Then we say, hey, the bounds is what we get from the partitioning, because we calculated there. Then we start the triangles from left plus the pivot. So that will give us, in this case, in the previous example I used, 255. What's correct. So we will start at 255, but the other one will go from 0 to 244. Because it's always less than count, right? And then the count is the complete count minus pivot. So in case we have 500 shapes, that's 500 minus 255. So that's 245. Yeah. Right. Wait, what? Oh, wait a second. Partition info. Oh. No, this is wrong. This is wrong. Yeah. Because it's info plus. So it's... Yeah, it's this, right? So... pull pointer and then the surface area. Yeah, wait. No, that makes sense why it was working incorrect. Because we're passing in the pivot. However, it's the pivot based on the offset what is first. So we're providing it simply with the wrong info. So this is magically work. But let me enable the Raytracer. And disable paint. Right, there we go. Alright, it's still building BVH. We're getting some very different values here. It's still running in debug, so it's quite slow. For some reason, it's not taking my console again. Oh, I keep having issues with the console. Okay, there we go. There we go. Now we have the console up as well. So we can actually see what I'm seeing in the console. So apparently, Visual Studio uses different, like the exe path is different for debug and release. So OBS only recognizes one of the two. So if I want to run a release and show the console, I have to switch it out in OBS. But not great. Right. Okay. You know, I'm already bored of this. Let's run this in a release. Because debug is so damn slow. Like, it's actually no joke slow. This bothers me. So it's... there's no cow. Frames are taking forever to render. However, we're not getting out of bounds errors anymore. That's progress. Right, so... oh, right, we still didn't have the... remove this test. Sure, so let's run this test again. See if this debug breaks. Oh, by the way, sorry, Mika, I just see that you followed me as well 20 minutes ago. Sorry, I didn't notice. Thank you for following. Right, so it's building the BVH. It's done building BVH. Okay, that's awesome. Right. So I think that fixed that. Well, fixed it in the sense that before it would simply debug break here because there was out of bounds, but we're now not running out of bounds anymore. And the BVH building, I think, is faster as well. Let's run it again and review the nodes. Because I hope now we don't see duplicate nodes. Right, let's rerun. Right, there we go. So, but I don't know if these debugs menus are actually readable, and I don't think I can increase the size of these. I hope it's readable. If not, I can look into settings and see if I can increase the size somehow. Oh, these values are actually... This is looking much better. What happens if I do 4? Does that... Oh, okay, that's a shame. We're still going. Right, so it seems we almost used all the nodes. What I suppose is a good thing. Maybe. Right, so this contains all one triangle. Sure. Yeah, this looks correct to me, from what I can see. Yeah, so I used it at first as well. However, once you... I don't know what you're using for programming. I'm guessing Visual Studio or VS Code. Using things like the call stack or the watch list can be very useful, especially with like things like these. Right, I'm just interested in all the values, and there are like 10,000 of them, so it can be quite insightful. But things like the call stack as well. The call stack is, I would say, one of my favorite things ever. So, say something happens in here. Let's say this debug break triggers. This does something, right? I want to see, oh, what function actually called that. I can go in the call stack and see, oh, the Raytracer called this. Where did it call it? Oh, it called it here. and I can go up in the call stack and see what's actually going wrong. What's so powerful that it's insane. So say something crashes as well, you can go back basically up in the call stack to see what is causing the crash, what kind of values that is. So it's easy to spot like when the crash happens, what function calls it, and it can help you a lot with debugging. Although like simple print statements can still be very useful because these are powerful, but they're not always the correct tool. Yeah, so for the call stack, it's basically how would the easiest way to explain? It's basically just a list of functions that you're into, right? So a function calls each other. So you start with the main, right? Then main calls loop app.run. App.run calls initialize. Initialize calls this, and you can go down that same call stack again to see what was calling it. So that's very powerful. The watches and the locals basically show you local variables. What can be useful. One thing that is really cool, but I have really mixed feelings about. So if you go to the breakpoint and click on settings, you can add conditions. So this is basically an if statement, right? So you can say if hit equals true, right? And this will not only trigger if this condition is true. However, I don't like them. Why? Is because these breakpoints are incredibly slow to use. If in some parts of the code they can be fine, but in a Raytracer, like your code will die. So what I would do is actually, if I want to test a condition, I would put an if statement around it. You would then put a breakpoint on the if statement because that runs much faster than the conditional break thing. So the conditional breakpoint can be useful, but it depends on how intensive the code is. So with the Raytracer, this code gets called thousands and thousands of times, like the traversal. Because what we're saying, like each triangle intersection is run 14 million times, right? So if you put a conditional breakpoint there, it's incredibly slow. But in some random place, it should be fine. Yeah. Yeah, cool. Sorry. I got distracted by debugging. Oh, yeah, right. I remember what I was doing. Raytracer close. Stop debugging. Right. No, it's fine, man. It's fine. Don't worry about it. I'm just a person very easily distracted as well. Even when just regular programming, I will go from everywhere to everywhere. But it's fine. It's completely fine. Right. So the building looks fine now. So do we ever intersect? So let's just have this render. So it's building the BVH still. You know, I might actually be able to multi-thread the BVH creation. That would be pretty cool. Because I think I could multi-thread each subdivide. I think that should be possible. Maybe. Right. So this does. Right, so kind of curious. So we're here. What do I want to check? Right. So the current count is 1, and left is something correct. And we never intersect them, it seems. We don't intersect at all. What is confusing? Where did it? Do I even? Okay, let's just actually do a sanity check. Right, so just to test, in the intersect here, if node dot zero dot intersect ray comma object distance return and model dot zero. Oh yeah, this should be model dot triangles. And then the address, right? Cool. And then we comment out this. So now we're simply saying if return no pointer, right? So this will not do any shading or anything, but we're now basically saying if we intersect the root nodes, return a triangle, because I need this for the test pointer. So I don't really care about what triangle I hit at the moment. I just want to see if I hit the root node, because I'm thinking, what if I did an oopsie, right, and I accidentally am like inside of the bounding box, but I don't think I am, because we can clearly see the outline of the bounding box. And yeah, this is running in reasonable time because we're only doing 1 in 6 per frame. Sure. So we are definitely hitting the box. So we're missing the triangles, all of them. I know maybe why. Right. So we do hit this, right? So this is debug code that we can remove again. So we have these. So with the traversal, right? We have some cheese here. Some cheesing here. If the left, let's put some breakpoints here. Let's see if these ever fire. So theoretically, right? Imagine we have 2 boxes. Do I have this on Paint? Yeah. I could use Paint to show this, right? So with Paint, make it a bit bigger, right? So imagine this is the array we're sending, right? So the run is the array. We hit 2 boxes. So we pick the box first that's closest, what would be the left node. And let's say there's actually an object here that we hit. Then we know for a fact that this box can't contain an object to intersect, because we already found one in a box that's closer. That means that this box we can just ignore and disregard. However, we might be doing it wrong. So I'm kind of curious if these ever gets triggered. Because they should be, because they're default no pointer. Yeah, they are. Okay, cool. And I kind of want to know if these ever trigger as well. So right ship is no pointer. To the right. So if right shape is traverse. Sorry. So if the left box is closer than the right box, then we traverse left first. That's just left, right, blah, blah, blah. So if we didn't find anything there, we go in the right box and we check left +1. Yeah, and if not, we check right first. Left +1. Yeah. And then we traverse again, but then on the left node. That should be fine. Okay. let's restart because I kind of want to see if this ever triggers as well. The multiplying by -1. And then remove these. Yeah, no, I know. It took me forever to write this as well because even though I understand what I'm doing, I don't understand what I'm doing. No, the idea is pretty simple, but wrapping your head around it is very, very hard. I remember the first time I made this, it took me 2 weeks. Like, no joke. So yeah, and it's really hard to debug till you get like anything working. Because I can't visualize anything. But the issue is I really have some easier to understand things planned. So I want to work on some UI and other stuff. However, I can't do that till like the Raytracer renders in like a reasonable frame rate, right? Because there's no point in making UI if the UI takes like 4 seconds to react. No point. Same with shading and reflection and refraction. It's only going to be running slower. So instead of 4 seconds, it's going to take 8 seconds per frame, and it becomes worse and worse to debug. So I really need the speed up first. What's kind of unfortunate. However, I would say this is one of the hardest things in the Raytracer, probably. It's very powerful. Right, so that I don't think that ever triggers. So do I have a case? So what do I return if there's no intersections? How is that redundant? Oh, right, because we just returned. Yeah, sure. So in case nothing, we return. Yeah, no, I've definitely had the same value. So sometimes I've had times where I've been like doing something for like an entire day, right? And then I'm like, at like 5, I'm like, okay, I'm done with this. I go to sleep, I wake up, and I sit again for it, and like immediately it's like, oh wow, I am an idiot. That's such a simple solution. But yeah, I would say it's probably simply because you're focusing too hard on one problem, and simply going for a walk or doing anything else, sleeping, will give you new ideas and will basically reset your brain, and you can solve the problem next time. Wait. Just realized something. So, return left shape. So I just realized something, right? So we're trying here to get the shapes, right? Left shape, right shape. However, we're saying if we're checking these, but we find them, we find it, blah, 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 doesn't really matter. Then we check if the right has a value but the left doesn't, we return the right shape, the shape on the right side. However, if we have left and right, we want to see which one is closer. But if it's just the left one, we don't actually have a test for that. I'm just seeing. Yeah. So what happens here? So do I ever reach this? Do I now magically have something? Come on, breakpoint. it's no pointer. Yeah, I would need actually something here. If left shape does not equal no pointer, debug break. So let's see if that ever gets triggered. I hope it does, because that would be silly if it, because that could explain why it was going wrong. And I kind of want to put a breakpoint here as well. If any of these two run, we would have a shape. Alright, don't think we're going to be that lucky. Yeah, I don't think this is going to work. Right, so there's one more sanity thing I can do. Yeah, this is not intersecting anything. Right. So I could do in the build in the intersect, right? Wait, didn't I have this in the Raytracer still? Yes, I do. Awesome. So, so this is model. Why is right? There should be a dot, not the arrow. And distance here is float. This is in infinity. Wait, do I not? Wait, where's infinity? There we go, infinity. And then sure. Return closest. Right, so now we're skipping the BVH completely, and we're just brute forcing it again. Okay, apparently we're not. Oh. We're gonna brute force it again. So now we should see a cow. So now we're looping over all the triangles again. Right, we see the cow. However, there is no shading. What's odd? Why do we not have shading? Because I did have shading before on this cow. But it could just simply be that my light is too far away. Let's put this a bit lower and a bit closer. We don't have shading at all. Okay. Odd. That's actually odd. Yeah, I know. So yeah, the reason I hard-coded it, because having shading, like just basic Lambert shading, is very useful in like seeing the object clearer. So I have one light to provide that functionality. However, since it's expensive to add more lights, I have skipped that for now till I have the acceleration structure in. So I would need some more things there. I think this was at 4 before. let's see what the shading is producing for kind of values. Interesting. So they are ray tracing, but it's just being slow, I'm guessing. Right, this might just take a while. But the shading shouldn't be... Because we're seeing the cow, right? Yeah. Let me see if release is any better. Yeah, cool. So we are producing not a number. Okay. Interesting. That is interesting. Let's just run without the breakpoint. So we're getting not a number. Okay. That is odd. You know, let's actually skip the PVH building for now, because it should speed up this by a lot. And then we do need the out here, because I can't really debug on... I can't debug on release, because it's too... it doesn't give the values. Let's just pray that this provides the runs to breakpoint so I can see why it's not a number. Because that would be odd if it's not a number. Oh, wait a second. Yeah. Oops. I know what's wrong. I didn't actually pass the distance, so the instruction point was an infinity, and that, you know, doesn't make sense. Yeah, release. There we go. We have an intensity that makes sense. There we go. There we have a shaded cow. Perfect. So the camera is definitely at the correct position. Okay. Interesting. But this is like hard coding the cow, right? What is obviously wrong. So, why is this wrong? Sorry, I shouldn't say why this is wrong. Why is it failing the intersection? So in the build, in the intersect, comment out this and re-comment this. No, that's double commenting, right? So uncomment this. So do I ever intersect? I don't think I do, but we can see. Alright. This is taking an awful long time to calculate as well. Yeah, there is. I think this part of Visual Studio. Yeah, so it's Control K, Control C. So you select lines, and you can press this button to comment those lines, and this button to uncomment them, or Control K, Control U. I think you have to press both of them. So Control K, Control C, and Control K, Control O. So comment, something like that. was quite useful for just uncommenting entire sections of code. Yeah, it does, right. So, okay, this is interesting, right? So, let me change my console, right? Right. So we can see the console again. We can see it's rendering. However, it's taking about 13 seconds per frame. What makes sense, as we're never intersecting with an object. And since it never intersects with an object, it has to calculate all the boxes in the scene and all the triangles. So we're doing even more calculations. What, is bad. However, the interesting part is why it doesn't intersect. As right, so right, so this should trigger, right. So the index is y. Yeah, basically, right. But in this case, we're looping through all the boxes, and we're looping over all the shapes. So it's much slower because for some reason we're never intersecting or never actually hitting the triangles in the boxes. What's odd, to say the least. Because if we look at this, so this is the index, right? So did I mess up the index by any chance? So it's first plus y. What is correct? So the left is the actual index, and a count is 1. So it would loop once. Okay, no, that's correct. So this is the actual index to the correct node. And this should fit as well. Yes, this is kind of a pain. We can't easily find the correct one, but I'm willing to believe it fits in the bounds, because otherwise in debug, like, this would have triggered. Anyway, so the debug breaks get hit, or should doesn't get hit because it's release. However, why do we not hit the triangle? Can I go inside this? Right. So this right, so this can I hover over this and see what the result is? No, sometimes it works. So if the normals play a factor. However, they don't play a factor in the actual intersection. They do play part in shading. So let's put a debug breakpoint here and see if we're actually ever hitting the triangle at all. Or, yeah, sure. Let me put it like that. So we can intersect a triangle. Oops. So triangle intersect, right? So we have an intersection here, and if we reach this line, but t is smaller than 0, it would mean that we intersect with the triangle, but we intersect behind us, because that's how the math works, right? So we have to check if it's actually in front of us. However, I don't think we're ever reaching that either. So I think we're basically reaching this, yeah. So determinant is very small. So pvac is the cross of the ray direction and that one. So I don't think we're ever getting past that. Are we actually? Oh, sorry, yeah. There are more returns actually. Do we ever get past it? The first one? Yeah, we do. Do we ever get past this one? We do, but we never get past this one because v is not less than 0. Yeah, so this one is true. Sorry, this one is false, and this one is true. So we return false. So we don't intersect it, right? So we never reach that part of the code. Okay. So it seems we never actually intersect them. However, what I'm confused about is how we're still missing triangles. Yeah, how are we missing triangles in the first place? This is... Wait a second. Okay, so hear me out, right? If the thing is going correctly, we should... Or at the moment, we're not intersecting anything, so that would mean that we run through all nodes. However, if we run through all nodes, that means we run through all models. And if we loop through all models, we should intersect, because we just hard-coded that and that worked. So that means that there's still something wrong with the nodes. That might mean that we're missing triangles. So let's try something crazy. Let's Raytracer, let's run this in release, PVH. So let's say we do less than or equal to count. A really crazy idea. So this will give us one more intersection. However, I'm curious if we actually ever run into anything. Yeah, this obviously gonna complain because it doesn't fit in the box anymore. But that's whatever. We can ignore that. Because I'm curious if we check one more, if that by any chance renders anything. And if it does, that would be pretty big. Oh. No, it's still completely green. Okay. Yeah, we're living on the edge here by adding more to the count. But yeah, I think there is definitely going something wrong with the partitioning still. Because if we go over all and miss all of them, that's impossible. Because we know we intersect at least one of them. One of the triangles at some point. We must. So, still going something wrong with partitioning. However, I think I've got to go now because my food is ready in a few minutes. And I have to do Christmas stuff with family. So, I might stream again later in the evening. But I'm not too sure. It might. I do kind of want to solve this, so I do think I will be streaming later today. So I want to thank you all for watching, and I wish you Merry Christmas. Yeah, I hope so as well. But I think we're close. I think we're very close. But yeah, do follow me if you want to get a notification when I stream again. So I might be streaming again in a few hours. That would be cool, and I might be streaming tomorrow, but I'm not too sure. Anyway, thanks a lot, man, for joining the stream, and have a Merry Christmas, and everybody else in the stream.